Good morning, guys. University Physics. Okay. This is your lab 11. The title of the lab is called Equilibrium of a Rigid Body. Okay. So you do, suppose you are here and you're doing the experiment. I am one of you. I'm doing the experiment for you and recording it for you. And the data table and everything will be provided for you. Thank you. Here, the rigid body is this meter stick. Okay. If you look at your page 1, apparatus, a meter stick. Okay. 3 meter sticks, knife edge clamps. Okay. 1, 2, 3. See, it's not. It will be at the center. Okay. And then stand for supporting the meter stick with clamp. Okay. Then set of hooked weight set. Okay. Then triple beam balance. Instead of that, I'm using a digital balance. Okay. And body of unknown mass, about 100 kilogram. We'll use 100 kilogram as if we don't know. Okay. Or we can use here 1 second. I'll run and get an unknown mass. Give me 1 second. Okay. I'll use an aluminum block. This is the unknown mass. Okay. So here you go. Now, if you measure here, if you look, I measure 1 by 1. Okay. Okay. It's like 0.605 kilogram. .604 kilogram, almost the same. And the center one, actually, we don't need. I take it back. We don't have to measure the mass because it doesn't participate. Okay. So doing that, you record all those things, and there is small couple of correction. If you look at it, page 1, procedure number 2. Okay. Weigh the 3 meter stick clamps. Instead of 3, call it 2, because as I said, this need not to be measured because it doesn't come to the calculation at all. Okay. So 2 meter stick clamps. It says together, say it separately, and record their weight in Newton, which is recorded for you. Okay. Now let's do the experiment. Okay. And in page 1, okay, if you look at weigh the meter stick and record the weight in Newton, we did it. It just come out something like, I recorded, and if you multiplied by 9.8, it's about 1.29 Newton. Follow everybody? Now let's do the experiment. Look at the procedure. We done number 1, number 2, weigh the 3 meter stick clamps. We did. Find the center of mass of the meter stick. So please watch. I'll leave it so that you can see. You insert it and keep it loose. Okay. And here you go. Here and then pretty much here. Okay. So tight it, and then I'll read it to you. So this is like 48.3. It's not at 50. It's supposed to be at 50. Okay. So you write it down. Okay. Then it says, okay, we find the center of mass. Okay. Now it says put another clamp near one end of the stick. Okay. And we put it, okay, in the table. Let's say we put it at 97.4. Okay, so 97.4. Okay, so watch now. Remember, the mass of the meter stick is at that point. Okay, now put it. Okay, now you have to balance it. Okay, and it says put the another clamp near one end of the stick and put 100 grams. Okay, here you go, 100 grams. Put here. Okay. Okay. Now draw it up at 97.3. 100 grams means what? 100 gram plus mass of the hook times 9.8. That is the force here downward. Now here remember the center of mass, right, which is mass of the meter stick times 9.8, which is the weight. That's why it's like a seesaw. Okay, it's balanced. Remember the torque. Torque, this one is clockwise. What is the torque? This lever arm, okay, times the weight of the meter stick. Clear? Here, this lever arm, okay, this is the pivot. Pivot, and where you are applying the force, that distance is the lever arm for this force. So you multiply this weight times this distance, you get torque, clockwise. They should be equal, right? You see, it's balanced. Okay, within percentage error, you calculate. Okay, I'll provide the data. I'll write down the equation for you. Okay, I'll show you the calculation, and so this part of the experiment is done. Okay. Now, procedure number 5. Put another clamp near the other end of the stick and suspend at 200 grams. 200 grams. I have another clamp. Okay. Now, okay, say put another clamp near the other end of the stick and suspend a 200 grams weight from it. Leaving the other weight in place, find the new point of balance by again sliding the meter stick through the supporting clamp. Aha. So let's put it the way we did. Okay. We put it at 36. Okay, here we go. 97. Okay. So let me put this guy at 30. Okay. Okay. Now you play with your pivot. Watch. Okay, so a little bit more in it because pretty much. Okay, so now you tied it. Now watch. What are the weights? This is at 29.4. Okay, and then you have the mass of the meter stick. Okay, so mass of the meter stick times this distance plus this weight times the lever arm should be equal to this weight times this distance, the lever arm. This should be equal to that. Okay, this is second part of the experiment. Okay, now log procedure 6. Remove the weights and clamps. Clamp the meter stick in the support clamp at its center of gravity. Put another clamp near one end of the stick and suspend the body of unknown weight. Okay, so here you go, take this one out. Take this one out. Okay, so remove the wires and clamps, clamp the meter stick in the support clamp at its center of gravity. Okay, so here you go. Center of gravity was what, 46 point something, right? It was here. Okay, now you put clamp okay, and so it said remove the wires and clamps, clamp the meter stick in the support clamp at its center of gravity, put another clamp near one end of the stick and suspend the body of unknown weight, slice another clamp in. Okay, got you? So you put it here, doesn't matter where, we'll write it down. Okay, and then you put an unknown mass. Okay, and then put another clamp. Okay, now all you do what? Okay, pretty much, right? So all you have to do, 200 plus okay, this mass times 9.8 multiplied by this lever arm should be equal to clamp plus this unknown weight. Our goal in this experiment to find the mass of the unknown weight times 9.8 meter per second square times this distance. Only unknown is this mass of this block. You put it in the equation and solve for it. Okay, so that's this experiment. Okay, and then you calculate by the moment of method, and then now actually you put it in electronic balance, find its actual mass, find the difference between them, percentage error. Okay, so basically that's the experiment. Okay, and all the calculation you do, answer the questions. Okay, then that's just a short lab. Okay, thank you very much.